to our research advisors. I am Shona and Ashley Pilia together with my groupmates, and we are here to present the findings of our study titled The Relationship Between Project-Based Learning and Practical Skill Development Among Third-Year Industrial Engineering Students at Bataan Peninsula State University. This research seeks to understand and quantify how utilizing project-based learning influences the growth of essential technical and transversal skills among our students. We will now begin with a look at our core objectives. Introduction. Project-based learning and student development. Education requires innovation and creativity to prepare students for real-world challenges. College students must become skilled, flexible, and independent learners. Self-determination fosters creativity and independent knowledge discovery. Collaborative and participate learning enhances motivation, creativity, and exposure to diverse perspectives. PBL promotes active hands-on, real-world learning that strengthens critical thinking, teamwork, and higher-order skills. PBL impact and teacher involvement. Shang 2022. PBL improves academic achievement, thinking skills, and real-life application of knowledge. PBL increases students' responsibility, confidence, and long-term academic growth. Almula 2020 says that PBL enhances engagement, collaboration, and information sharing. PBL helps students develop problem-solving ability, conflict management, and appreciation of the different viewpoints. Educators plays a key role by designing structured learning activities, guiding exploration and integrating technology. Successful PBL implementation makes students proactive, innovative, and adaptable to real-world demands. For a research gap, traditional learning often limits hands-on experience. Current teaching methods often rely on lectures, which can limit students' opportunity to gain hands-on practical experiences needed for real-world engineering problems. Second one is few studies locally, especially in BPSU, explore how PBL affects both technical and soft skills. While project-based learning is used, there's a lack of local evidence, especially here at Bataan Peninsula State University, that systematically measure its impact on both the students' technical skills and essential soft skills. Last one is the study bridges theory and practice by focusing on PBL exposure versus practical skill development. This research directly addresses this gap by providing empirical data on how much PBL exposure converts classroom theory into measurable practical skill development, making the learning process more effective.
Statement of the problem. This study investigates the relationship between project-based learning and practical skill development among third-year industrial engineering students at BPSU main campus. This study seeks to describe the demographic profile of respondents in terms of sex, age, and section. So it also determines the students' level of exposure to project-based learning based on the frequency, duration, and complexity. It assesses their practical skill development in technical and transversal skills. It identifies if a significant relationship exists between PBL exposure and skill development. The objective of this study is to determine the relationship between the project-based learning and practical skill development of third-year industrial engineering students at BPSU main campus. The specific objectives is to assess the students' level of exposure to PBL, evaluate their practical skill development in technical and transversal skills, and identify the significant relationship between PBL exposure and skill development.
Methodology. Our study focuses on determining the relationship between project-based learning, exposure, and the practical skills development of our third-year industrial engineering students. Research design. Use a descriptive correlational design to determine the relationship between project-based learning and practical skills development of third-year BSIE students at BPSU main campus. We use a descriptive correlational because this design was chosen because its descriptive part allows us to characterize the students' exposure to project-based learning and their current skills level, and its correlational part is specifically designed to determine if there is a significant relationship between the two variables. Respondents of the study. The respondents of the study focus only on the third-year industrial engineering students at Bataan Peninsula State University main campus as they are at the crucial stage for skill development and application. Our study exclusively focused on the third-year industrial engineering students at Bataan Peninsula State University main campus. They were selected as the focus group because they are at a crucial stage in their academic program where skill development and application are paramount. Sampling procedure. Employ simple random sampling to give each student an equal chance of selection and reduce bias. We employ simple random sampling to select the participants from the target population. The target population consists of 103 third-year Bachelor of Science in Industrial Engineering students enrolled during the first semester of the academic year 2024 to 2025 at Bataan Peninsula State University main campus. These probability sampling techniques ensure that every student in the target population has an equal and independent chance of selection, which is vital for reducing selection bias and increasing the representativeness of our sample. Research instrument conducted through Google Forms after approval and validation. Data were tabulated using Excel and analyzed for correlation between project-based learning, exposure, and skill development. Our primary research tool was a structured questionnaire using a 5-point Likert scale. The instrument was validated by experts to ensure its appropriateness and reliability. The data collection was conducted through Google Forms after securing all the necessary approvals and ethical clearances. Sampling procedure. Data gathering procedure. Conduct through Google Forms after approval and validation. Data were tabulated using Excel and analyzed for correlation between project-based learning, exposure, and skill development. Once collected, the data were tabulated using Google Sheets and Microsoft Excel and analyzed to determine the correlation between project-based learning, exposure, and skill development. Statistical treatment of data. To truly analyze the data and answer our research objectives, we employed both descriptive and inferential statistics. Descriptive statistics. These tools are used to summarize and describe the characteristics of the data collected, frequencies, and percentage. Used to describe the distribution of respondents based on demographic variables such as age and gender. Weighted mean. Determine the average level of project-based learning, implementation, and practical skill development. Standard deviation. Measure the consistency and variation of responses among participants. Relationship test. The primary test addresses the core objective of determining a significant relationship. Inferential statistics apply to test hypotheses and determine the relationship between project-based learning and skill development. Person person are person product moment correlation used to identify the strength and direction of the relationship between the two product variables. In summary, our methodology is use a descriptive correlational design, simple random sampling, and the person R test to rigorously investigate the impact of project-based learning.
Results. The first table shows the respondents' sex. The respondents were 17.20% male, 39.78 female, and 43.01 who preferred not to say, which shows most are female and many choose to keep their sex private. In Table 2, it is the respondent's age, wherein most students are 20 to 21 years old, followed by 18 to 19 years old and 22 and above years old. This shows that the sample is mostly young adults. For the third table, it is the respondents section. Respondents came from Section 3A, Section 3B, and Section 3C, with Section 3A having the highest number of students with 44.09%. In the fourth table, this shows the frequency of the project-based learning. Students always experience project-based learning with a composite mean of 4.58. This means that project-based learning activities are frequently included in their subjects. For the fifth table, duration of project-based learning with the composite mean of 4.58 shows that project-based learning activities usually last several weeks, giving students enough time to complete their projects. For the sixth table, complexity of project-based learning with the composite mean of 4.58 indicates that students often work on real-world complex and problem-solving projects. For practical skill development, first is technical skills, wherein students rated their technical skill development at 4.56, which means always, and shows that they can apply theories, use tables, and solve problems effectively. For the transversal skills, with a composite mean of 4.58, students say that they always develop soft skills like communication, teamwork, and adaptability through project-based learning. Lastly, in our correlation table, the correlation coefficient is R equals 0.706 with a p-value of 0.001, showing a strong and significant relationship between project-based learning exposure and practical skill development.
For the conclusion of our study, we found that project-based learning or PBL has a significant positive effect on the practical skills of third-year industrial engineering students. Most of our respondents were young adults aged 20 to 21, and many of them came from Section 3A. Based on the results, the students are regularly exposed to PBL activities which include hands-on and real-world projects. Because of this, PBL helps them develop important skills such as decision making, problem solving, teamwork, communication, adaptability, and leadership. Their technical skills were also rated at a high level, although there is still room for improvement in some specific areas. Statistically, we found a strong positive correlation between PBL exposure and practical skill development, with a correlation value of R equals 0.706 and a p-value of 0.001, which is less than 0.05. This means that the more students engage in PBL, the more their technical and soft skills improve. Overall, the study confirms the PBL is an effective teaching approach for developing both technical and transversal skills. Because of this, the null hypothesis is rejected, and we emphasize the importance of continuous PBL integration with proper guidance to better prepare students for real-world professional challenges. For our recommendations, first for students, we encourage them to take a more active role in PBL activities. They should collaborate more, practice self-directed learning, and seek feedback from their teachers and group mates to improve both their technical and transversal skills. For the teachers, we recommend that they continue using PBL in their classes. Teachers should create realistic and meaningful projects and provide regular guidance, monitoring, and reflection activities. Attending seminars or training about PBL will also help them improve how they implement this approach. For the schools, we suggest strengthening institutional support by improving laboratory facilities, equipment, and other resources that support hands-on learning. Schools should also promote interdisciplinary projects and build partnerships with industries so that students can experience real-world application. For curriculum planners, we recommend increasing the number of PBL-based subjects and encouraging collaboration among teachers. Monitoring the outcomes of PBL will help make sure that their curriculum continues to match industry needs. Lastly, for future researchers, we recommend exploring additional factors like motivation, learning style, and teacher support. They can also conduct comparative studies between different programs or year levels to understand PBL's broader impact on skills development.
Thank you for listening. This is a research for the statistical analysis 2 about the relationship between project-based learning and practical skill development among third-year industrial engineering students at Bataan Peninsula State University main campus.